Hey everybody, welcome to Solutions Day 3. So today we're going to be able to calculate molarity and solve dilution problems. So get your calculators ready and have a periodic table handy. Molarity. What is this? Molarity is basically a measurement of the concentration of solute in solution. It is expressed as the number of moles of solute dissolved into 1 liter of solution. So we can look and see the picture on the left has a lot more moles than the picture on the right. So we have probably heard of the term concentration before, but this is our fancy science word for concentration. So concentration is just a ratio of comparing the amount of solute to the amount of solvent. If we look at these pictures, the one on the far left side does not have very high concentration. It's very, what we would say, watered down. Whereas the picture on the very far side has a lot of solute. So if you dumped in extra Kool-Aid packets into your same amount of water, you would end up with something very concentrated. So really what a high molarity means is that it is a very concentrated solution. If I was looking at these two, the glass of the water with the Mio in it versus just the Mio water enhancer, the Mio water enhancer, this picture on the right, is much more concentrated. So usually you take this here and just put in a few drops into the water. So it is very, very concentrated. And this bottle of chocolate syrup is much more concentrated than the diluted chocolate milk. So the chocolate syrup has a higher molarity. So when we are calculating molarity, all you have to do is use this formula here. The capital M is equal to moles of solute divided by liters of solution. If the solute is reported in grams, the first thing you need to do is convert it to moles. So if they give you 45 grams, if that's my given, I'm going to put that over 1 mole. I'm going to divide that by the molar mass, which is from the periodic table, of NaCl. So this 58.443 came from the mass of the sodium plus the mass of the chlorine. So you're going to need your periodic tables today. Okay, so if I added together those two masses from the periodic table, that's where I got this number from. And then I divide these numbers, the 45 by 58.443, that's how I came up with my moles. Okay, so step 2 is to divide the moles of solute by the volume in liters. So it's a pretty simple formula. So we're going to switch over to document camera and work some examples. Alright, my first problem says if 0.5555 moles of sodium chloride is added to 0.25 liters of water, what is the molarity? Okay, so always start by boxing your givens and circling your unknowns. Okay, box and circle. My formula is M is equal to mole divided by liters. I already have it in moles, so I don't need to do a conversion. So it's as simple as saying M is equal to 0.555 mole divided by 0.25 liters. So I just need to divide these two. And I got this answer right here. 2.22. So my M is equal to 2.22, and that's it. That's my molarity. And we can put like a big M to represent molarity. All right, my next problem says if 0.72 moles of lithium bromide is used to make a 1.5 molar solution, what is the volume? So this is a little bit flipped from before. So previously we were solving for M. This time we have M. And we have moles, but we don't have volume. So we're solving for L. So we got to do a little bit of equation rearranging so we can get L by itself. This is my big M. This is where the moles go. And I'm looking for the liters. So in order to get this by itself, it's like we just need to do the opposite of what it says. So it says divide. So we're going to move this to the other side. We're going to move it to the other side in order to solve for L. So we got to get L by itself. And I often tell students, hey, if you struggle with rearranging equations, here's a little quick trick I like to do, because it can be hard to know what to multiply and what to divide. So in order to make it easier, I'll model you a little sample equation that I think is very helpful. I like to think of a problem that is really easy that I can do off the top of my head, like 5 is equal to 10 divided by 2, for example. Okay, because I know very easily then how to manipulate this equation. So my liters here is in the spot of this 2. And I know that in order to solve, I just need to make that true. So to get 2 here, I would say 10 divided by 5 equals 2. That's how I know how I can rearrange my equations successfully, because I want the same thing to be the case on my actual numbers. So I have these, so I'm going to make this my numerator, 0.72 divided by 1.5, and that will give me liters. So my answer is 0.48, and you can always check your work in chemistry. So if I'm not sure if I did it correctly, plug in your answer and make sure it makes a true statement, right? So if I divide these two, if I put in 0.72 divided by 0.48, I want to make sure it equals my answer. And it does, so I know I did it correctly. All right, next problem, it says if 142 grams of calcium chloride is added to 0.5 liters of water, what is the molarity of the solution? And we gave you a hint, hey, first you need to convert those grams to moles. And even before that, we have to remember how to write our formula for calcium chloride. So calcium chloride has a formula of CaCl2. And before I do anything else, I need to turn this grams into moles, just like I did up top. Okay, so I'm going to start with the given. That's where I always want to start. And then I'm going to just go down my units. Grams of calcium chloride is equal to 1 mole. Then I'm going to just use my periodic table because I need to figure out the molar mass. All right, calcium. Calcium has a weight of 40.078, and I have one of those, so I'm going to put it in my calculator. And then I'm going to add that to the weight of 2 chlorines. So 2 times, and then chlorine right here, it's got a mass of 35.453. Okay, so my molar mass is 110.984. And now I'm going to divide these. 142 divided by 110.984. And that gave me my answer in moles. So 1.28. We're going to round that up a little bit. And now we just need to plug it back into my original formula, which is M is equal to MOL divided by liters. So I'm going to say 1.28 divided by 0.50 to get my final answer. So my answer is 2.56 capital M for molarity. Okay, so let's keep going with dilutions. We use dilutions when we use one solution to make another. So we know this commonly as watering something down. And we use this formula, this M1V1 is equal to M2V2 in order to solve these problems. So if I had something that was too strong, I could add some more water and get it to the concentration that I wanted. Okay, so once again, always box and circle, box and circle, box and circle. All right, it says if I have 25 milliliters, that's my M1 of 0.0142 m KCl, that's my V1, and it's used to make an 84 milliliter solution, so that's my, I had these reversed. Oh no. This is my volume, and this is my molarity, so that's better. V2 milliliters is volume. What is the concentration of my new solution? So what is my M2? So if I put this in my equation, it's going to look like this. My M1, 0.0142 times 25 is equal to M2, which I don't have, times 84. This is very similar to the way you would solve Boyle's law. So I always tell my students multiply the pair and divide by the one that's left over. So I'm going to multiply these two and divide it by this one to give me M2. I like to do it all in one step. So it would look like this when I plug it in. Right? And then I'm going to divide by 84. Okay, so that gave me a really small number, but that's okay. And if you're worried about it, you can always check your work. Remember, if you check your work, if I wanted to check, I was worried I did it wrong, I could multiply this by 84, and to make sure it gave me the same as what is on the left side. So if I hit enter and it equals 0.355, then I know I did it correctly. And it does. So this is my answer. My M2 is equal to 0.0042. Okay. Next problem. What volume of a 2.5 molar? Okay, so this is my M1. Would you need to prepare 600 milliliters? This is my V1 of a 0.2 molar solution. So this is my M2. So I'm looking for my V2. So once again, you want to multiply the pair, multiply the two that go together, so I'm going to say 2.5 molar times 600 milliliters, multiply the pair, and divide by the other one that's left over to get what you are missing. So I'm going to multiply these two, they are the pair. I'm going to divide by my other m in order to solve for my V2. So that's my equation. I want to multiply these and divide it by the other, and that will give me my V2. So you can do it all in one step. So I'm going to say 2.5 times 600, hit enter, and then divided by 0.2. So my answer is 7,500. My V2 is equal to 7,500 milliliters. All right, one more example. I have 1.52 liters. Okay, this is liters, so this is my V1 of a 1 molar solution of sodium hydroxide. This is my M1. Is used to make 2.5 liters. So this is my V2. What concentration? So I'm looking for my M2. Once again, you want to multiply the pair, the two that go together, and divide by the one that is alone in order to solve. So I want to multiply these, 1.52 times 1.00 divided by 2.5. That will give you my M2. Okay, and there is my M2. So it is, M2 is equal to 0.608. And that's it. Don't forget, your left and right sides are going to be equal to each other. So if I want to check my work, I want to make sure that both are equal. You can always plug it back in and do that. Okay, so I could say, I know 1.52 times 1, that is equal to 1.52. So if I multiply 2.5 times 0.608, I also want to see that that side equals 1.52. And it does, right? So you can always check your work in chemistry, and I encourage you to do so. All right, that's going to do it for today's video. Great job.